Okay, we're back. This is Techmath2. We're looking at section 8.8, revolutions and rotational velocities. So let's take a look. 2 revolutions, they want to know how many degrees is that. So if you go around, think of it as going around the circle. So if I go around the circle 1 revolution, 360, 2 revolutions, 720 degrees. If I did that round and round and round and round 10 times, it would be basically 10 times 360, so 3,600 degrees. All right, easy peasy, easy enough. 10 rev/sec means 10 revolutions. Revolutions per second is what that means. All right, 3 RPS, revolutions per second, and they want me to make it into revolutions per minute. So we're just going to use our little stoichiometry, just multiply by a fancy 1. 60 seconds is 1 minute. And now look what happens. The seconds cancel, and we're left with minutes. And so 3 times 60 is 180 revolutions in 1 minute. Or this is how mathematicians look at it. This is how the rest of the world looks at it. RPMs. So 180 RPMs. Okie dokie, artichoke. Okay, let's look at linear velocity. Linear velocity just means if I had, did you ever see them when they're marking off the road with, they're drawing like the line on the road. They've got a wheel that just keeps turning and paint that just kind of plops on it, and that wheel turns, and that's how they get those lines on the road. All nice. So think of it like that, but think of it as a point being marked on the wheel, and then what's the distance? How long is the line? And so here, they want to know, look at 66 on page 367 in the red book. For 8.9, we want to know 1 revolution. How far would it go if the circumference were 5 centimeters? So if it just went 1 full rotation, if we think about this here, I've got a roll of duct tape right here. So think about it. If I was unrolling the tape, I'd like put the piece down and then I rolled it 1 full rotation. How far would that go? Well, it would be the circumference. So 1 rotation, if they tell us the circumference is 5 centimeters, 1 rotation would be 5 centimeters. It would travel 5 centimeters in 1 rotation. In 3 revolutions or rotations, I called it a rotation, sorry, revolution. So 3 revolutions, 1, 2, 3. How long? Well, it would be 5 on the first one, 5 on the second one, 5 on the third one, so that would be 15 centimeters. And 10 revolutions, that would be 50. Just 10 times 5. All right. So now they up it a little bit. Do they up it a little bit? Nope. Same problem. 67. It's just they said, what if the circumference were 6.28, and then it went 5 revolutions? So you would just take 6.28 if the circumference were 6.28. We would just take 5 times 6.28, and that would get us 31.4. And then if they said 81.7 revolutions, what a weird number. We'd take 81.7 times 6.28, and that would get us, round a whole number, that'd get us 513 feet. Okay. And then they up it a little bit, they up the game a tiny bit, where they say, okay, what if, oh no, they don't really here. Not yet, not in 8.9. Let's take a look at 71. They said a point travels 456 centimeters in 12 seconds. And then they want to know the centimeters per second. They want to know its linear velocity. So really, we're just going to take, in 12 seconds, we just want to know its linear velocity is how many centimeters in 1 second. So we would divide top and bottom by 12. Even if that means I'm going to get a decimal here, I'm still going to divide by 12. Now, it does work out where it's exactly 38. So, but even if that would have worked out to be 38.7, I'd still put 38.7 centimeters in 1 second because we like that centimeters per second. And so we always want the seconds or minutes or the time per hour, we always want it to be 1. All right? Okay. And then 77. Let's look at, that's the one that I thought I was on here. 77 is they give you the radius. So they say a wheel has a radius of 36 centimeters and has a rotational velocity. A wheel with 36 centimeter radius has a rotational velocity of 225 revolutions per minute, RPM. We want to find the linear velocity of the point on its circumference. So that means we have to figure out the circumference first. Remember, circumference is equal to 2 pi r, right? Or pi times diameter. So we'll call it 2 pi r instead of pi times diameter because they gave us radius. So 2 pi times 36. So circumference, that would be 1 revolution. 1 revolution would get me, let's pop that into the old calculator. 2 pi times 36. Is 226.194. All right, they're going to have me round to a whole number. We'll still go a thousandths place for the work. 226.194. That's a good general rule to follow. Oops, 946, so we'll call it 95. Like thousandths place. And then they want to know the centimeters per minute. So if it travels 225 revolutions in 1 minute, and now think about this, we want centimeters instead of revolutions. Well, we know 1 revolution will cover 226.195 centimeters, right? Because that's its circumference. So if the circumference of the circle is 226, then 1 revolution, full rotation of the wheel will cover 226 centimeters on the ground. But then there's 225 of those in a single minute. And so the revolution crosses off with revolution, and we just do the 225 times 226.195. And so that is 50,893.8. So we'll call it 50,894 centimeters per minute. And then they said, hey, why don't you convert it to meters per minute? And so, well, how many centimeters are there in a meter? Isn't that 100, right? Think of a meter stick. A meter stick has 100 centimeters in 1 meter. And so if we want to get rid of centimeters here, we can go 894 centimeters in 1 minute. We want to keep the 1 minute, but we want So 1 meter is 100 centimeters, according to our meter sticks, right? So the centimeters cancel. We're dividing that basically by 100. And again, if you said, oh, I don't have to do all that, I can just divide by 100 because I know that. That's fine. Meters per minute. And they want whole numbers there again. So 509 meters in 1 minute. So the linear velocity, that's called the linear velocity. All right, then let's take a look at the angular velocity. Omega. They're going to use omega, but the small version of that, not the large version, so it kind of looks like a W. It looks like a funny W. It's the lowercase Greek letter omega. So it kind of looks like it's got like a W, but kind of squared off a little bit, or rounded off. So what is that? That is angular velocity, is this guy. And T is the time. And angle rotated in radians. Okay. Omega. All right, so let's look at 79. Well, they already kind of did it for us there for 79. They said, look, theta is equal to 51 over 6. Or how many radians? Well, you just divide, so it's just 8.5 radians. So they're just kind of reminding you how to transform 51 centimeters if the radius is 6. So a central angle whose arc length is 51 centimeters and whose radius is 6, we're just converting it to radians. So remember, arc length is equal to radius times theta. Well, that also means then theta is equal to arc length divided by radians. So they just used a little algebra on the formula that we used a couple of sections ago. All right, so let's look at 84 here and see what we can do there. So it says complete the following conversion in one step by using 2 unity factors or unity fractions at the same time. So again, that branch of mathematics is called stoichiometry. It's when you're multiplying by 1 essentially. And so you just have to look at what they gave you and look at what you want. So they gave us 140 revolutions, RPM, so that's revolutions in 1 minute. And then you have to look at what they want for an outcome. They want it in radians per second. So they want us to convert this, oops, I'll put an equal sign way over here, to radians per second. So you just have to think, okay, well, revolutions, 1 revolution is equal to 2 pi radians. Remember, like radians? All right, so 360 degrees, same as 2 pi radians. And minutes, we want into seconds, so 1 minute is 60 seconds. And now look at what cancels. The revolutions cancel, and we're left with radians, that's what we wanted. And the minutes cancel, and then we're left with seconds, and that's what we wanted. So if you take 140 times 2 pi and then divide that by 60, that will give us our final answer here, if you want to write 280 pi radians in 60 seconds, but we don't want 60 seconds, nor do we want pi in our answer. So you just stick that in your calculator and then divide it, and that'll kick out 14.7. And that would be radians per second. Okay. All right. So linear velocity and angular velocity. Let's jump. How many more sections do we have? Oh, you know what? I'll do 11, 12, and 13 next.